Welcome to massive open online course. Myself Dr. Sivasankar. I am working as a teaching faculty in Department of Geography, University of Madras. So, as a part of practical session, we are going to discuss about cartographic technique, where we are going to emphasize map projections. So, this complete session, this discussion is completely on map projections. We are going to understand what is map projection as such, different types, different classification and basic concepts. Let us get into the presentation. This is the overall content of presentation, where we will be starting with introduction to map projection, classification of projections, types of distortions, common projection and its various applications, and various technical concepts. So, this is the overall picture, where this is the core topic which is there in projection. So, we have to have a clear understanding on this. So, then only we can have a better understanding. So, this is map projection overview. It is a fundamental concept which we are going to discuss in detail, and we are going to discuss the different types of projections and application and cartographic projections. This will be very much useful for undergraduate geography students as well as the geospatial beginners. Let us understand what is projection as such. Look at the image what you are seeing right side. Look at the globe. It is in 3-dimensional view. Okay. The bottom what you are seeing, it is 2-dimensional flat map. Okay. So, the conversion of this 3-dimensional, the spherical or ellipsoid 3-dimensional view into 2-dimensional view known as projections. If you read the definition, it is a systematic transformation of 3-dimensional view or 3-dimensional spherical or ellipsoid surface onto a 2-dimensional map. Okay. This not to make it very simple, just we are converting from 3-dimensional to 2-dimensional flat surface map. Okay. This is very challenging, okay, because since earth is in curved in nature, making flat it is not that easy. If you have started pushing to flat surface, always there will be a distortion. Okay. Distortion in the sense like in terms of shape we may have a distortion, in terms of area we may have a distortion, in terms of distance and direction we may have a distortion. Okay. So, though this is a basic understanding of projection, again in order to make it very simple, just we are converting earth 3-dimensional dimension into 2-dimensional map. So, that is the basic definition of map projections. Why we need to project a map? Why we have to use projection in geography? This is very important. Okay. This is very important because geography involves spatial analysis. If you want to perform spatial analysis, okay, you need to have some measurement and metric system. Okay, in terms of spatial analysis, in terms of navigation, in terms of planning or decision making. Okay. So, we need to have the metric system. So, in order to perform all these things, we have to have a appropriate projection system, and we have to choose the projection with minimal distortion. Okay. So, when you choose right projection, we can minimize the distortion. Okay. So, distortion in the sense as I discussed earlier, we can have a clear measurement of distance, area, shapes and directions. So, these all comes under we are minimizing the distortions. Okay. And the projection is very essential for GIS and remote sensing application. Okay. Because in order to identify the accurate spatial relationship, okay, we need to have the complete understanding on projects. Suppose you are working in any projects, you need to have a complete understanding on projection. Okay. So, you have to decide which project needs which projection system. If you are working with worldwide globe wise projection, then you have to choose appropriate projections. If you are looking for any regional base, for that you need to have a separate projection system. If you are looking for any single point or any particular location, for that you have to use different projection system. So, in geography, projection is playing very crucial role in order to perform spatial analysis, in order to reduce the distortion, and in terms of application GIS and remote sensing, the understanding of projection is playing very crucial role. So, with this understanding, let us move on to the next slide, classification of map projection. Here we can see 3 types of projection. One is cylindrical projection, Okay, I will tell you what it is, and the conic projection and azimuthal projections. So, these are the basic classification of projection. This is completely based on the surface. By seeing the surface, okay, we can have this classification. Okay. Let us begin with cylindrical projection. So, look at the image. Okay. This is the globe where you need to wrap the paper paper around this earth in equator. This is the equator somewhere here. If you wrap it around this globe, okay, so this will help you to generate the cylindrical projection. Okay. In order to have a clear surface in and around the equator, so probably we are using this cylindrical projection. This projection system, keeping the direction accurate, the people when they use for navigation and all, mostly they will be using cylindrical projections. Okay. Example is Mercator projection. And one more disadvantage, if you are moving towards equator to polar region, there will be a distortion. Okay. Distortion in the sense the area, if you calculate the area wise, the shape wise, you can see the distortion. Okay. So, cylindrical projection, it is nothing but if you are placing the white sheet around the globe, okay, so this particular surface may be projected and we can fetch the appropriate result out of this cylindrical projection. Okay. So, we have done with the cylindrical projection. This is mainly for preparing a navigation map. Next one is conical projections, placing cone over the earth. Okay. Look at this picture, okay, where one standard and two standard parallel. This is one standard and this is two standard parallel. Okay. This particular projection system, okay, it is a good balance of shape and area accuracy, The previous projection system will help you to maintain the shape. Here also the good balance of shapes and area accuracy for mid latitude countries. The previous projection cylindrical projection, we are used it for equator and surrounding countries, whereas the conical projection, it is very much suitable for mid latitude regions. Okay. Here also same thing, if it is increase away from the standard parallel, then probably it will throw the error. It will throw the error in the sense there we can see more distortion. Standard, this is a one standard, this is a two standard. Away from this, then probably you may see the distortion. Okay. And example is Albert equal area projections. It is best used for a regional or national map for mid latitude countries or mid latitude zones. So, this is the basic understanding of conic projection. Let us move on to azimuthal projection. Again, look at the image again, and so we are placing the sheet. This is a sheet which you are placing on the globe. Just we are connecting. Look at the definition. Imagine pressing the flat sheet onto the one spot of the earth and projecting the feature directly it. So, this is the flat sheet and one point, let us say this is the pole. Okay. If we start projecting, only these area alone will get projected. Keeps the directions and distance correct from the center point. Okay. So, the previous conic projection, what it does? It will retain the shapes. Okay. This particular projection, azimuthal projections, it will keep the directions and distance. Okay. It will preserve direction and distance from the center point. Again, from the center point, if you move towards the the outer periphery, then again there will be a distortion. That is what I am saying. The second point, if it is very accurate near the center and distortion increase towards the edges, that is what I mean to say. This will be useful for particularly for polar region. It is for if you are projecting polar region, this particular projection will be very useful. And example, what you are saying, it is a stereographic projection, best used for polar map and radio communication map and airline routes. For all these application, we can use azimuthal projections. So, we have done with the basic classification. Okay. Now, we are moving on to distortion in map projections. If you are converting 3 dimensional into 2 dimensional features, okay, there will be some distortion. Distortion in the sense, okay, either so here I have listed out all the distortion. shape conformality, and area equivalence, and the third one is distance or equidistance, and direction azimuthality. These are the distortion predominantly we will be seeing whenever we are projecting 3-dimensional into 2-dimensional flat map. Let us understand one by one what is shape as such, what is area as such, what is distance as such, and direction. Okay. Let us begin with shape and conformality. Look at the definition, it is very simple. It map preserves local area and shapes of the small area. It preserves local area and shapes of the small area, and it maintains angle, the map useful for navigation. That is the second point. The third one, shapes are preserved. See, the title itself, shapes. So, shapes are preserved, whereas area may be greatly distorted, especially near the pole. As I said, like every projection from the center point, if we move away from the center point, there will be a distortion. So, very good example for this shape conformality, it is Mercator projections. Look at the image. So, this is retaining the shapes. This is the actual shape of Africa and Greenland. Okay. In Mercator projection, what it does, okay, due to this distortion, like from the equator towards north, due to distortion, the Greenland, it appears it is equal to Africa. So, this is the distortion effect. Okay. So, here it retaining the shapes, okay, it is retaining the shape, whereas in terms of area, okay, in terms of area it is highly distorted. As a part of distortion, here this particular projection retain the shapes, whereas it compromise the other parameter like area, distance and directions. Okay. Let us understand this image. Assume that this is the 500 meter radius circle. So, this is look like smaller here, near to the equator, whereas it is moving from equator to polar region, where you can see this circle, it is here also it is 500 meter, but still this circle appears larger than the equator area. So, this is how we can understand the distortion, right. Okay. So, the same circle what you are seeing in equator, it is completely bigger than equator here in northern pole. Okay. This is how it is getting distorted. Here it retained the shapes. Look at North America and South America and Africa, India, it retained the shapes, whereas area wise it is greatly compromising. That is the reason why I have drawn this circle, and it will make you understand better. Okay. Then now the equal area maps or area preserving map, okay, area preserving map, which preserve, because title itself is very clear, it will preserve the area, but compromise with shapes. Okay. So, compromise with distance and directions. Okay. Right. Look at the the clear definition, land area in the correct proportion to the real size. Okay. The land area correct proportion to the land size, the shape of the zone or whatever it may be, it look like stretched or fused, especially near the pole. Look at this boundary. Okay, this was basically created based on the Mercator projection. Here the shapes are clearly maintained. Look at the green color boundary, it clearly says that it is where area is highly retained. If you measure the area, it is highly matching with the real time. Okay. If that is the case, here it retained the perfect area, but if you look at the appealing look, it does not maintain any shapes. Okay. For example, Gall-Peter projection and Albert-Uckel area projections. The primary application for the equal area projections, we may use it in thematic map showing the population distribution and agriculture and resource mapping, because all these are comes under area calculation. We are not going to compromise with the area, and environmental studies where area are compromised. See, if you are comparing with one area with other area where you do not want to lose any area, for example, if you take cadastral map, if you take tax map where you do not want to compromise any area, like even 10 square feet of land, it matters. By the time if it is a area specific, you have to use area specific projection like Gall-Peter projection, Albert equal projection, like that. Okay. Here it retained the area. Okay. Area wise there is no compromise, it match with real time earth, earth shapes. Okay. So, we have done with the equal area maps. Now, we are moving into distance, equidistance. So, here we are concentrating on distance. Suppose you are working with a project where you want to retain the distance, okay, where you do not want to compromise, where you do not want to have more distortion in distance, then probably you have to use equidistance. Okay. This equidistant projection, it shows the correct distance, okay, and along the certain lines or from one core point. See, look at this image. So, what we have seen in Mercator, it is going from equator to towards pole, there we can see large number of distortion, whereas what you are seeing here, it is almost almost similar. See 1, 2, 3, and if you are moving towards the polar region, it started disturbing. Okay. So, if that is the case, if you want to work with distance based projections, then probably you have to use this particular projections. And one more thing, this distance may not be accurate for everywhere on the map, that is also very important. As I said earlier, okay, so in certain line or certain point, from there if you are starting in and around that point, there will be a clear which means there is without error we can have a actual distance. If you are moving away from that central point, then probably it may throw the error. If throw the error in the sense what, there will be a distortion, there will be a huge variance. Okay. For example, for this projection, equidistant conic projection and azimuthal equidistance, this projection can be used in order to, if you are working with any distance preserved projection system. Look at the application, very interesting, air travel route planning, because if you take air travel, it is completely rely on distance. For that we can use this projection effectively, and radio communication coverage on particular radius, how much area it covers in terms of distance, where we can use this, and military application requiring distance calculations. So, if any military operation needs a distance calculation, probably this projection will give you the better result and better understanding. It will lead to the precision operation. So, then let us move into the next distortion, it is a direction, azimuthality. Look at the key character, keep the direction correct from the central point, similar to what we have seen in the direction distance. Best for showing shortest route or flight path. This is the one of the the vital application recent days we are performing. Okay, all these recent application which runs through shortest path algorithm. This projection is very essential, because this preserves the directions. Okay, sometimes distance as well, sometimes not always. Look at the third point, if you are preserving direction, then distance, size and shapes may still distorted. That is what, if you are preserving one parameter, let us say direction, the other parameter will get disturbed, like distance, size or shape, whatever it may be. Example, azimuthal equidistant projections. Okay. If you are working with, again let me repeat again, if you are working with direction based project, shortest or optimum path or flight path, whatever it may be, you have to choose these projections in order to get the better result. So, understand this diagram, again from the center point, if you move towards the outer boundary, then it started distorting, then slowly the direction the direction detail also may get distorted. If you look for primary application where polar region mapping, if you are if any projects which deals with polar region mapping, probably they will be using this, most probably they will be using this projections. And flight planning for long distance route, flight planning for long distance route, this is very essential. And military strategic planning, okay, for same thing what we have seen in the distance, same thing. For radio transmitted, both distance and directions have sometimes it will complement each other, right. So, we have done with the distortion, then this is the overall picture, okay. This is the overall table, it will make you understand very clear. So, conformal, it will retain the shapes, example Mercator, navigation and meteorology. Equal area it will preserve, mall wide projection and Albers for thematic mapping. Equidistance, distance from the line, using azimuthal equidistance, we can preserve equidistance, distance measurement and radio range. Azimuthal, it is a preserve the direction, mnemonic projection, navigation, great circle. One more thing, like being a cartographer, you have to have a clear understanding which projection system you have to use. You have to ensure that best fit the specific purpose of the map. Whether when I say specific purpose, whether you have to see whether it is a shape specific or it is a area specific or it is a distance specific or direction specific. Being a cartographer, you have to decide which distortion need to be eliminated, which one need to be retained. The next, projection type by region. Let us say if you are working with global scale, then probably you have to use cylindrical projection. It is best for world map and global navigation purpose. Then if you are looking for regional scale, then you have to go ahead with a conic projection. It is ideal for a region in mid latitude. Okay. This is ideal for region in mid latitude, right. Example, Albert equal area projection and Laber conical projections. Then if you are going for special purpose, let us say like if you are working with azimuthal projection, work for best for polar region and directional mapping from the single point, you can use stereographic projection or orthographic projection. This is for global scale and this is for regional scale and this is for special purpose map. Again, by seeing the region, by seeing the purpose, by seeing the project requirement, you have to choose the scale. Then commonly used projection, when I say commonly used projection in the sense, okay, so predominantly this projection is being used frequently. Mercator, we know that it is mainly for marine navigation or web mapping, we are using Mercator projection. Nowadays web mapping on all web mapping process, they are using Mercator projections in order to have a the precise measurement or precise matrix. It preserves the direction and shapes, significantly distort the sites near the pole. As already we had discussed, it preserves the directions. If you are working with the directions, the Mercator projection directly we can take and use it. Even shape, again going from equator to near polar, then you start distracting. Then Robinson, it is useful for world map for general reference. It will balance the distortion. It will give the clear visual appealing. Okay. Goods projection, it is mainly for thematic. If you are working with the population, okay, it is mainly for all sort of thematic map. Then Lambert conical projections, based for it will be useful for aeronautical chart. Again, it is useful for mid latitude region. Good shape preservation and mid latitude countries or region, whatever it may be. Let us move on to the next topic, how to choose the right projection. This is very important. Being a cartographer or if you are a geospatial expert, you have to be very clear and choosing the right projection. If you are not choosing right projection, then probably you may not get the accurate result. That is very important. So again, identifying the regions we have discussed now. Okay, in global level what you have to do, and regional level what you have to do, and local level what you have to do. So okay, for global level directly you will be considering Mercator and similar kind of projection. Local level, of course you know what to do, azimuthal projection. Regional level, conical projection, like that you have to decide. So you have to look for the location specific which projection you are going to use and determine critical property. Okay. As I said earlier, this just I am summarizing. Okay. So you have to see whether by seeing the project requirement, by seeing the purpose, you have to decide whether your project or your practical work needs to preserve shapes, then you have to choose the appropriate projection where shapes can be preserved. Then area, like you are like as I said earlier, if you are working with any area calculation or whatever it may be, cadastral mapping or tax mapping, whatever it may be, where you do not want to compromise with the area, then you have to choose appropriate projections. Okay. Where area need not to be compromised. Okay. Then directions, use azimuthal projection, just now we have discussed, and distance, equidistance. Okay. The final one, you need to consider the application, whether you are going to use it for navigation, whether you are going to use for thematic map, whether you are going to use for any kind of planning. Okay. So before you choose projection, you have to consider all these 3 points. Okay. Identification of region, scale, okay, and determining the critical property and considering the application area, everything you have to plan. So, then only you can have appropriate and more accurate result. Okay. So, in cartographic, that is the reason why I am saying that in cartography projection is playing very crucial role in terms of you are working with measurement, in terms of working with area calculation or any spatial analysis. So, projection plays very crucial role. And along with the projection we need to understand the earth shape model. Okay. So, again this is value to the projection, you have to be very clear on these concepts, because if you are working with the geospatial technology or geospatial software, you need to mention the respective geoid, you need to mention the sphere and ellipsoid and all you have to mention, then on in order to get the accurate result. Okay. Geoid nothing but this is the shape of the geoid, okay. The model based on the mean sea level and gravity variance. Okay. Precise the elevation measurement, if you are working with have a more precise output, if you are looking for precise output in terms of elevation measurement, this geoid need to be considered, this geoid need to be need to be considered. Okay. Sphere nothing but this is the sphere, a perfectly round approximate of earth, simple but less accurate. Here problem is that it is very perfect approximate the earth, it is not actual, it is approximate the earth, but simple less accurate. Okay. Look into ellipsoid, it tried to match the actual shape of the earth, it is not approximate, it tried to match the actual shape of the earth. Okay. It flattened sphere widened at equator. So, look at here in equator it is somewhat wider, whereas in pole side you can see the flattened sphere. Very good example WGS 84 used in GPS system. That is what I am saying, if you are working with geospatial software or working with any survey, land based survey, small station whatever it may be, or any drone survey whatever it may be, you have to have a clear understanding on what is geoid, sphere and ellipsoid. Okay. So, if you have the clear understanding, then probably we can get the better output. So, next one is understanding datum. Datum is very simple, it is a reference framework that combines ellipsoid model with the reference point, okay, in order to create the coordinate system. It is a reference framework. Okay. And for example, WGS 84, okay, that is World Geodetic System 1984. This can be used for complete globe. Okay. It will try to approximate where any part of the world we can, it has the, even most of the geospatial software they are using these projection systems. Okay. It try to fit in for complete globe. Then NEAD, this is a region specific, especially for Northern American datum 1983. Okay. This is region specific. When you use this, when you are working with the projects, okay, when you are working with any practical work is respect to the Northern America, where you have to use this datum in order to get the precise output, precise result. Okay. This is for complete globe and this is for North American countries. And different datum can give slightly different coordinates for exact same the physical location. Let us say for WGS, let us understand clear WGS 84 and this is for NEAD 83. Suppose assume that this is a zone. So, using WGS you are plotting the point somewhere here. If you are changing the datum, what will happens? That point has slight shift, because we are changing the the complete datum point. Okay. But this NEAD, it is very much suitable for North American, where you can have more, whereas even does not mean even you can use WGS, both will have there will be a minor distortion, but it does not mean that you should not use, you should use this one or that one, either this one or that one. Okay. So, depends, if you are looking for more accuracy, cadastral level mapping in US states, then probably you can use NEAD, or else for any generic purpose directly we can go ahead with the WGS 84. Okay. This is the basic understanding of datum. So, next one is coordinate system. We can have two systems, one is geographic coordinate system, other one is projected coordinate system. This will work with the lat long value with the degree, this one will work with xy coordinate meter and feet. This is based on the ellipsoid and datum. okay, it is for generic mapping, whereas this will projector system will work with the accurate distance and area. This is global level mapping, okay, we can use the GCS projection, whereas for local level mapping we can use projected coordinate system. Okay. So, now to make it very simple, GCS nothing but globe based coordinate system and PCS flat based coordinate system. Let us move on to the next one, transformation between the projections. From one projection to other projection we can easily transform based on the purpose. Look at here, why this transformation is needed, because we will be collecting the data from different sources. So, that this transformation is very essential, and any specific properties again we need to have this transformation and for particular purpose. And if you are moving into types of transformation, there are we can go for either datum can be transferred or else projection system itself can be transferred. So, here I have given the example from NAD 83 to WGS 84 we can transform, we can from Mercator to Albert equal area projection we can transfer, and this transformation we can done through geospatial software in order to have the better result. These are the various application area, okay, marine navigation, regional mapping and global thematic mapping and urban planning. So, everywhere this projection playing very crucial role. Okay. So, with this these are the key takeaway. So, here we have a clear understanding on map projections, how it can be transformed from curved to flat, and classification of surface. Based on that we have seen cylindrical, conical, planar, and property preserve shapes, area, distance, direction, again we have discussed all those things. Okay. And one more important point, okay, no single projection preserve all the properties. Okay. So, if you are saying that I need to preserve shapes, area, distance and direction, no single projection will preserve all the property, there will be some, you have to compromise certain properties. Okay. Choosing the right projection depend on the purpose, region, property to preserve, and understanding geoid, ellipsoid, datum and coordinate system is very essential for accurate mapping for geospatial analysis. So, with this I am closing the session. Thank you so much for giving me this opportunity. Have a great learning. Thank you so much.